Hi all. This is the second part for the ER model. In the first part, we discussed about the entity sets and the attribute, various kind of attributes that we draw in along with the entity sets. We are left with the relationship sets in the last lecture. So let's first discuss about the relationship sets. Okay. So, what are the relationship sets, right? So, it relates between two or more entity sets. Okay, so we have entity sets that represent a collection of similar kind of entity, right? So, if we have two entities of different kind, then relationship sets relates two or more entity sets. Okay, so now how does it relates? First, let us look at the symbol. We know we have the oval symbol for the attribute, and then for the entity, we have the rectangular symbol. For relationship sets, we have this diamond symbol. So this is the symbol for relationship sets. Let's see, we have two entities. Let's say this one is E1 and second entity is E2, and we need to show the relationship between them, so we will represent the relationship set as R, and this way we can show the relationship between two entity set. So we are using two entity set, so that is why this relationship is called binary relationships. Okay, since this relationship is between the two entity set. Okay, similar way we have, let's suppose E1, E2 and E3, three entity sets, and we need to show the relationship on all these three. So these three are related using this relationship set R. So this is a three-way relationship, so it is known as the ternary relationship set or relationship. Okay. So relationship set can relate n entity set. It is not only about binary or ternary. So important point to note is relationships can relate n entity set. Okay. So that is why it is called n-ary relationship. Okay. So this thing is an important thing to note. One more thing, that for the same entity set, suppose E1 is an entity set, we can have the relationship on the same set as well. Means some of the entities are related to some other entities using this relationship R. This type of special relationship set is known as self-referential relationship set. We are going to discuss more about this in the upcoming part. So this is self relationship set. Okay, so now these way we can have the relationship between the entity set. For example, let's say we have an entity of students. Let's say we have picked up some students information from the school, and we this is the entity set of the students, and they have the attribute that is the S name, and of course, we have a key attribute called SID, right? So this is one entity set with some attributes. Now, we have another entity set that is the course. So for every school or university, we have some certain course which has a certain CID, that is the unique attribute, key attribute. And for every course, we have a course name, of course, C name. Now we have these two entity set, and we need to relate which student has taken which course. So we will definitely need a relationship set. So how we'll represent it? So this is our student with the student name, S name, and of course a key attribute, SID. right? And then we have our course entity set. So we have this course with a course name, I mean C name, and we have a CID, that is the course ID, that is the unique attribute. And these two are related by a relationship set called enroll. Okay, and this way it is. And this enroll has also a attribute called fee. There is some associated fee with a particular course. So this fee is a kind of descriptive attribute because it will differ for each course. We can have this fee attribute inside the course as well. For each course, we can have the course fee, but we have this attribute with the enroll because it has something to do with the student also. So maybe this is kind of attribute associated with this relationship set only. Okay, so now in this way, we have just designed our ER diagram, right? For the students who have enrolled in some of the course in a school. Okay, so this is the ER diagram. Now, how do we actually design the next step and what are the next step? Because we earlier have studied about the 6 steps for designing the ER model. So we have the student, of course. So for the student, we have a specific SID, that is the key attribute, and we have the S name. Okay, so we can represent them in a table like SID and SName. There will be a table for students. Then we have a table for enroll as well. And we have a table for course as well with CID and CNAME. Okay, with CID as the key attribute. Okay, for the course. Now this is our enroll table. This is our student table, and this is our course table. Okay, now in this enroll table, we are going to associate a student with the course. Okay, so we definitely need to have the SID and the CID because student will be identified with the SID and each course will be identified with the CID. So this will be the key for enroll, and we have one more attribute here, that is the fee, which is somewhat intrinsic to the enroll set. Okay, so this is the key for student, this is the key for course, and in the enroll we are mapping this SID with this CID because we have not chosen S name or C name here because course name can be same. Okay, or a student name, two or more student can have the same name, so definitely we are going to pick up the unique value in so as to relate between these two. Okay, so it is something to do with the key, right? So this is the primary key here because if we are looking at the student set, we need sorry, it will be key. Right, so if we are looking at the student set, then for each student we have a unique key, that is the SID, because for each student, two student can have the same name, but definitely the enrollment number or the registration number, that is the ID, will be different for every student. Okay, similar way for each course, two course name can be same, but the CID, I mean the course ID, would be different. So this is a kind of primary key for this course entity set. For enroll, we have taken the two primary keys from these two and have added these as a single attribute, and this is the primary key for enroll. Okay, so this way this SID refers to this and the CID refers to this, right? So this way we have designed the database table for the above entity relationship model. Okay, so we have this primary key and SID is a in the enroll, SID is a foreign key referring to student. Okay, And CID is a foreign key. SID is a foreign key referring to student in enroll. I mean in enroll relationship set. And CID is a foreign key referring to course in course entity set. Okay. So this way we have designed. Now, foreign key are required to represent must be required to represent the relationship sets. Okay, we need to have this foreign key so that we can show the associativity between the two sets, right? Now, let's discuss about the constraint associated with the relationship sets. Okay, constraints associated with relationship sets. Okay. So there are two constants. First is the participation constant. We'll be discussing about each of them. Participation constant. And second is the cardinality or mapping constants. Mapping constants. Let's discuss about each of them because then only we will be able to understand the ER model completely. So first one is the participation constant. Okay, so these are the constraints associated with the relationship sets only. Okay, and relationship sets act between are relates between two or more entities set. Okay, so for two entity set, for example, here we have E1 and it is related by a relation R to, let's suppose, E2. This is an entity set. Okay, so if every entity of E1 is are related to every entity of E2, then it is said to be a total participation. Like all the entities are related to all the entities of E2, then the relationship would be total participation. Like we have entities all in E1 are related to all in E2. Very important. Okay. So if every entity of entity set are related to the relationship set, then there will be total participation. Otherwise, in any case, if some misses out, it is called partial participation. Otherwise, partial participation. Okay. So is that clear? Every entity of entity sets must be related to the relationship sets. Must be related to the relationship sets. If every entity of the entity sets are related to the relationship sets, then it is called total participation. Otherwise, it is partial participation. Very important to note this because the other points that we are going to discuss are based on this. So this is about one of the constraint. The second const. Okay, let us give an example for to explain this part. For example, we have two entity set. One is the employee, okay, and other is the department, okay, and we have a relationship called manage. So each employee is a manager of any department. So now let's say for the employee we have the key attribute as EID and ename, but this is an important part here. And for the department we have DID, department ID, and in the manage relationship set we have EID and DID, as the key attribute. So let's say in employee set we have four employees, E1, E2, E3 and E4. These are the EIDs of a four employee, and there are three departments with D1, D2 and D3 as DID. Okay. Now this E1 manages department D1, E2 manages department D2, and E2 only manages department D3 all. Okay, so E2 manages two departments, right? Now, here you see all the departments, all the DIDs are involved in this relation, but all the employees are not involved in this relationship. Okay, so this is a partial participation. Because all the employees are not related in this are not coming in this relationship. So if every entity of the entity set are not related in the relationship set, it is a partial participation. But here all the departments are involved in the relationship set, so it is a total participation. Is that clear? Great. So these are things are important. What is partial participation and what is total participation? Let's come to the second constraint that we have is the mapping constraint or the cardinality constant. Mapping constraints or the cardinality constraints. Very important. So mapping constraint is the binary relationship mapping because we can have n-ary relationships also, but we are right now focused on the binary relationship models for explaining this mapping constraints. So in binary relationship models, we have the two entity set, and there is one relationship set mapping those two entity set. Okay. So now in the binary relationship model, we can have the mapping as one to one. I'll explain what is this one to one, one to many, okay, many to one, and then we have many to many, okay, right? We have this four mapping constraint. One to one, I mean, one is represented by a single arrow. This represents one, and many is represented without this arrowhead. Okay, so this is many. These are the just symbols. Okay, so let's see what are these. Let's see what is one to one mapping. One to one mapping. Okay, so let's say we have one entity set E1 and another entity set as E2, right? And both are related with a relationship R. Now to represent one to one, we need to have this arrowhead here. Okay. This has some key attribute called A. This has key attribute called B. Definitely it will be having AB as the key attribute. Okay. Now let's say for the A, sorry, let it be visible. Okay, so in the even entity set, we have different entities such as A1, A2, A3. These are the values for a attribute. Okay, so these are four attributes associated with A. Definitely for E2 also, we have the attributes B and it will having the value of B1, B2, B3 and B4. So these are the four entities actually whose values are B1, B2, B3 and B4. This is the key value because each entity is represented uniquely with this value. Okay, and there could be other values also. Now in the relationship set ABR with the attribute AB, A1 is related with B1, A2 is related with B3, and A3 is related with B4. Okay. Of course, if you talk about the participation, This is a partial participation. This is also a partial participation. Okay. But here we are going to talk about the mapping. So this is A1, this is A2, this is A3, and this is B1. Of course, this is B3, and this is B4, right? So this A1 is related to B1 only. It is not related to any other attribute. This A2 is related to B3 only. It is not related to any other attribute. This A3 is related to B4 only. It is not related to any other apart from B4. So one entity of this is mapped to one entity of this. This is called one-to-one mapping, right? So this is the key here, and this is also the key here. So in AB, we don't have this as a composite key, definitely. We will have as a key and we will have B as a key. Okay, because A1 is associated to B1 only. We can't have the entry here as A1 B2 or A1 B3 or A1 B4. A1 B1, A2 B3, A3 B4. Okay, so one entity of E1 is associated with one entity, only one entity of E2. That is why it is called one-to-one mapping. And when it is one-to-one mapping, then definitely in the relationship set, A is a key, B is a key. Okay, so this is an important thing to note here in one-to-one mapping. So to preserve one-to-one mapping between E1 and E2, keys of the relationship should be A and B, right? This is the one-to-one mapping. Let's see about one-to-many and many-to-one mapping. So, okay, so the second one is one-to-many mapping. Okay, now in this, we have this E1 entity set and we have this E2 entity set, and both are related with the relationship set called R, right? And here we have this mapping. It shows one entity of E2 is related with many entities of E1. Okay, one to many. This is one and this is many. For example, if we have A1 here, A2 here and A3 here. Okay, and if we have B1 here, B2 here and B3 here. Okay, so in the relationship, it will be something like A1 is mapped to B1, A1 is mapped to B3, A1 is mapped to B2. It could be like this. I'm just giving an instance. So A1 could be related to many of this entity. Okay. So one to many means this kind of thing. So A1 is associated with B1. A1 is associated. Okay. I may have misplaced this. Just a second. Let me draw completely along with the attributes as well. So this is one to many mapping, right? Sorry, this will be 1. This will be 1 with the arrowhead and this will be many. I'm so sorry for that. Okay. So now let's say we have in E1 we have an attribute A, another attribute as well. It is a key attribute. In E2 we have the attribute as B and also other attributes. So for A we can have the values A1, A2, A3 and A4. For the B we can have the values like B1, B2, B3, B4 and so on. Okay. And for R we have A and B. Okay. Now let's see which will be the key. But first we are seeing the mapping. So A1 is, so here one to many. I mean one attribute of A entity E1 is related to many attribute of entity E2. So A1 could be related to B1. A1 could be related to B2 and A2 could be related to A3 or B3. Sorry. B3. But here you see two entities of E1 are related to, sorry, same entity of E1 are related to two entities of E2, right? This is the A1. It is related with two separate entities of B, right? So obviously we can't have this A as the key in the relationship, okay? But since here we can have B1, B2 and B3. So definitely B would be the key for this, okay? Because this part will be unique, but this part won't be unique, okay? So this is an important thing to note. To preserve one to many mapping, this many part, I mean one attribute of E1 is related to many attribute of E2, then the candidate key for a relationship set with A and B will be B only, okay, not A. So this is an important point to note here, right? So it is clear. So E2 object allowed to relate at most one attribute of E1, while E1 object allowed to relate zero or more object of E2. Let me recall this once more. This is E1 and one to many. This is one, and this is the relationship set R, and this is many, and this is the relation entity set E2. So here 0 to 1, okay, and it could relate to many, like 0 to infinite. So the thing is here, like it is just a representation to explain what we have already done. So E2 object can relate to many attribute. E2 object can allow to relate to at most one attribute of E1. Okay, E2 object allowed to relate at most one of E1 object. Okay, and E1 object allowed to relate zero or more object of E2. Okay, so this is clear. Let's come to the third part, and the third is just reverse of this, many to many mapping. Because again we don't want to have many to one mapping. It is clearly understood that in that case also, in many to one mapping, A will be the candidate key. For example, we have already seen. So let's see about many to many mapping. So this is even, this is important because many times we have this kind of mapping. This is the key attribute A, and there's a relationship set R, and then we have another attribute set E2, and we have the key attribute for E2 is B. Okay. Now for the relationship, so it has one or more E1 could map to one or more E2 like this. And if we see about the mapping, how it happens, so for E1 we have this A, and for E2 we have this B. Okay, so this is the key attribute. For A we have values like A1, A2, A3, A4. For B we have values B1, B2, B3, B4. We have this relationship set R, AB, and A1 is related to B1, A1 is related to B2, A2 is related to B2, and then we have A3 is related to B2. So B2 is mapped to three entities of E1, right? Similar way, A1 is mapped to two entities, and A2 is mapped to one entities, A3 is mapped to one entity. Similar, it is a many to many mapping, M to M, and when it is an M to M mapping, we can't have this separate as a key or this separate as a key, we will have AB as a key. Okay, so this is important that in the relationship set, the candidate key will be AB as a composite key. So we can write it as to preserve M is to N mapping, that is M in many to many mapping only. To preserve M is to M mapping between E1 and E2, the candidate key of R will be is AB as a composite key. Okay, so this is a very important thing to note. We will be having discussion about this more in the next video, discussing some of the examples of the mappings, and after that we will design some ER diagram into the minimal RDBMS table. That is the third step. Okay, so let's check it out next. Till that, goodbye.